Go on to work and power. Okay, so work is a quantity which measures the amount of energy done by action. If you want to think of it that way, it's very difficult to describe what work is. Work is a very, very complicated topic that the MCAT only very briefly covers. Work is just like, that's how engines like are made. That's how like refrigerators, everything works, but we're covering it very, very briefly for the MCAT. The main equation that you will have to know is work equals force times distance times cosine theta. The units of work is joules, which is the same unit as energy. So again, we know F is force, D is distance, and cosine theta, I'll explain in a second. So essentially, if you want to think about it this way, work is just force times distance. If you apply a certain force over a certain distance, that's how much work you do, right? Cosine theta refers to directions. Again, we talked about vectors. It's a difference in angle between the force you're applying and the work is being done. So if you're applying a force forward and then the work is being done like kind of at an angle, that's where cosine theta comes in. It's different, by the way, from the incline that we mentioned earlier. So like this alpha is not equals to theta, the 60 is different. It's a little bit different, but they'll give you a theta if they ever ask you for this. But most of the time, the difference in angle is 0 degrees, in which case when theta is 0, cosine theta is 1, and it just basically gets removed and it's just force times distance, okay? There's also the quantity power written as P, which is measured as work over time. Again, if you do a work over a certain time, you get power, that's the equation. The units of power are watts or joules per second. Watts is the standard. The simplified version, joules per second, is more of a kind of like fundamental, where it's like work is joules, time is seconds, joules over time. Okay. If you combine the two equations, you get power is equal to force times distance over time, because force times distance is equal to work. Right? Does that make sense? I'm very briefly covering these because work and power are not huge topics. Any questions? Okay. Yeah, and just to mention, like, work and power is very small topic on the MCAT, but if you have any specific questions, if you encounter any practice questions, please email me, come to office hours about work or anything like that. Now I want to get to more complicated force topics, starting with torque. So when you apply a force onto, like we were talking about a block, you can move the block laterally, which means just side to side, up, down, whatever. More complicated situation is when you apply a force onto some kind of arm, lever, hinge, anything that pivots. For example, on a door, you apply a force on a door, the door doesn't just move this way or like this way. The door, it rotates, it pivots, it opens or closes, right? Same thing with like your arm around your elbow. Your elbow is the pivot point. You apply force to your arm like this, the arm, it rotates, it pivots, right? This is called torque. Torque is you can think of it almost as like a scaled force that is being applied to a pivoting object. What I mean by scaled is that not all of the, in a sense, this is kind of like a not like textbook definition, but not all of the force is going straight into pushing the object, right? And the equation for this is torque equals force times distance. And I know it looks like a T, but it's actually not a T. It's the symbol is not a T, it's a tau. They just look very, very similar, but it's a Greek letter T. The tau is equal to force times distance. Distance measures the distance from the application of the force to the point of pivot. For example, like going back to my arm, the elbow I mentioned is the point of pivot. So if I apply a force here, it's a very short distance from the pivot point. If I apply force here, it's a longer distance to the pivot point, right? And that's what distance measures. If I go like maybe even further here on this side of the elbow, the distance is again short, okay? It's always from the pivot point. So for a door, it would be where the hinges are. For like a seesaw, it would be in the middle. where it pivots around. Okay. So again, the hinge on door, the middle of a seesaw, elbow on an arm, right? So the result of torque, like I mentioned, is not lateral movement like it normally is with a force. Like you don't, if you push like a door, it doesn't just like move forward, it rotates, right? It's rotational movement. Applying to an object either rotates it clockwise or counterclockwise rather than moving it laterally. The direction is something you may need to figure out based on the direction of the force and which side the hinge is being applied to. This is mostly just like kind of like logical, and you'll be able to figure out when you're given a diagram. If you apply force on like a door in this direction, it'll open up, it'll rotate this way. If you apply force in the opposite direction, it'll rotate the other way. If you were going on a seesaw, going this way would go rotate it this way. Applying a force upward would rotate it another way. Going on the other side of the seesaw would rotate it a different way. Okay. It's something you have to figure out. Before we move on to the next poll question, you guys have any questions with how torque works? So I want to mention that before we move on, actually. So the closer you are, and you may like be familiar with this, the closer you are to the point of pivot and the closer the force you're applying to is the closer to the point of pivot, the less actual scaled force is being applied. This is where I was getting at with it before. So if you think about it like a door, if you apply force right where the hinge is, if you're trying to like push on a door right where the hinge of the door is, it's really hard to open a door. If you push a door all the way on the edge where the knob is, it's very easy because you're very far away from the point of pivot. If you're very close to the point of pivot, it's hard. You need to apply way more force in order to get the same torque. Whereas if you're far away, it's much easier. And you can see that in this equation too. If you have a very small distance from the point of pivot, the torque is going to be very small. Whereas if you apply a force far away from the pivot, even if it's a smaller force, the torque is still going to be really high just because of the distance, right? Again, with your arm, if you want to think about it, applying a force here, it's very hard to move your arm. Applying a force here, very easy to move your arm like this way and that way, rotate it. Okay, so pushing close to point pivot is very difficult, is what I'm getting at. Much more difficult than pushing it farther away. So let's get to this poll question. I'm gonna relaunch the polling.